Dear students, this is Abraham, and today we are going to go over the discussion sheet for week 10, problem number 3, money balls. So let us look at the question. We are drawing dollar bills out of a bag consisting of R red balls and B blue balls. We get $1 for every blue ball, but whenever we draw a red ball, the game stops and we retrieve the amount of money we have made so far. Find the expected value of the money made from this game. So when we first look at this question, it is kind of confusing because we have a bag. Let's say over here. We have different numbers of balls in here. And we don't know which each of the colors are. And we grab some of the balls out. Until, let's say that this was a red ball, and you grab that one out. And then we stop the game. But we don't know how many more other balls are in here. And we don't know the specific positions of those balls. Because, we're grabbing it out of the bag and we don't know like the pre-computed positions. However, even though we don't know, we could rewrite this whole thing in a different type of game, an equivalent game that is easier to compute. So, instead of having all of these things hidden in our bag, let us assume that we pulled out every single ball. So this is going to have B plus R slots. Let's say that this was a B, this is a B, this is R, this is B, R, B, B, R. Okay. It doesn't really matter how we arrange these, right? Because no matter what, we're only going to be looking at the ones that come before the very first red ball. This is an equivalence game, and therefore we can organize our balls in this manner. Now let us look at this again. Let us say that we have only 1, 2, 3, 4 red balls. Then how do we figure out how much money we can make if we're grabbing these balls from left to right? Well, just like what I said before, it's just everything before the first ball, right? And if it's everything before the first ball, then how many positions do we have in order to make money? Well, we have R red balls, and we have R plus 1 positions for where the blue balls can go. And therefore, for each ball, we can create an indicator variable. What would this indicator variable look like? Let me put this to the side first. These indicator variables would just be the probability that the ball lands in this position. And where is that position? Remember how we have R plus 1 positions? Well, 1 out of R plus 1 positions, right? This is the probability for each indicator variable. Let us call it xi. Xi is blue ball number I in a certain position. And in this case, the first position. So therefore, xi can be defined in this way. 1 if bi in first position and 0 otherwise. And this will be our probability. Now let us try putting this all together to figure out what the expected value is. Now remember, the definition of expected value is going to be the sum at each x probability that x equals x. Sorry, this is supposed to be uppercase x. Let me make that more clear. Okay. Of all x's that are in our world. Okay. And in this case, we have xi's equal to x, and we're trying to find the probability of that. Okay? And our x's are either 0 or 1. 1. In this scenario, because our world is going to be blue balls, we have the summation of k equals 1 to b of 1 times the probability that x equals 1. This thing, like we found before, is simply this. Our x is going to be xk, right? And we have b of these. So it's going to be b times the probability of that, so 1 over r plus 1, which will give us b over r plus 1. And that will be the answer. Now let us look at part B. Find the variance of the amount of money made in this game. Now remember that there are a few ways to calculate variance, but in this case the easiest method for us, because we already know the expected value, would be e of x squared minus expected value squared. We already know the value of this, so right now we only need to worry about the value of this. Now, how do we figure that out? Well, notice that this x, we don't specify which x that is, so we need to look at two cases when the x's are the same or when the x's are different with our indicator variables. Because this x can be split into x1 plus x2 plus dot 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 plus xk, where k equals to number of blue balls. If we square this, we will get values such as xi squared or xi times xj, and nothing else because we are squaring the value only. So let us look at this value first. Now what does xi squared really mean? Xi squared is only 1 when the probability, it's only 1 when xi is 1. 1 when xi equals 1. 0 otherwise. But we already know the probability where xi equals 1. And that is what we found above. 1 over... Oh, sorry, my pen is dead. 1 over r plus 1. That's the probability. So the probability of xi squared is still 1 over r plus 1. And how many i's do we have? We have exactly b i's. Well, k in this case, but because we have b blue balls, we can just use b. So that would be these values. Now we have to look at this case. This case is a little more complicated. But let us go back to the scenario where we had multiple positions. But instead of looking at B balls and and red balls, let us just look at the red balls. Let's say that all of these were red. And like we said before, we only want balls that are over here in the first position. We already know the probability of the first one. It's going to be 1 over r plus 1. But how about the probability of the second one? Well, now we can have a ball that is, for example, over here or over here. That is 2 positions out of r plus 2 positions. So we multiply this together, and we will get 2 over r plus 1 times r plus 2. That would be for this case. And how many such pairs do we have? Well, if we have B blue balls, we will pair each one exactly one time with another ball. So, that'll be B times B minus 1. Because remember, we also have to go back like that, so there is no divide by 2 in this case. And if you don't believe me, you can verify it yourself with some basic algebra. So, we have B times B minus 1 such pairs, multiplied by that value. The sum of this will give us what we wanted to find, x squared. So let us put this all together. We have B over r plus 1 plus 2b b minus 1 over r plus 1 times r plus 2 minus our expected values squared, which we already found to be r plus 1, b over r plus 1 squared. And I'm not going to simplify this, but this is our variance. And that is the solution. Thank you.